Hello everyone. Welcome to this webinar on log processing with Ballerina and Humio. My name is Anjana Fernando. I'm a director of Ballerina Ecosystem Engineering at WSO2. I have worked with Ballerina earlier, so I have mainly worked the Ballerina core, VM, and data integration areas. And also my co-presenter is PJ Haggerty. He's the founder of Defibrillator.io and a developer advocate at Humio. And
hey everybody, how you doing?
Yeah, so he'll be picking up from the middle from the presentation after my session. So so let's get started. So this session will basically be first about Ballerina, the language, how it's special, what our aims in using Ballerina, and then we go to like how the integration with Humio basically improves our capabilities and our log processing abilities. So I'll start with the first part. Yeah, so a bit of a history lesson. So the crazy customer demand has led to the rise of companies like Google, Uber, and Amazon. So so what they do is because of this, they have led to build very complex systems to meet the customer demand. So so if you look like how they have evolved with this, what they have done is they have created a more disaggregated architecture to handle this. And we have seen this trend over the decades, as you can see here. So disaggregation means with these components, most of these become network accessible as well. And these ones, we call them as endpoints. And these can be things that expose data, applications, APIs, microservices, and so on. So with this, everything becomes a programmable endpoint. And this number of endpoints are exploding. So the apps we generally write become dependent on these endpoints. And integration means the discipline of resilient communication between these endpoints. So when we have all these endpoints going around, so we need a proper way to communicate, and we have to make sure these communications are happening properly. So this is not an easy problem to solve, because there are things like compensation transactions, even circuit breaking, discovery, and so on that comes into the picture. And these are all hard problems that we have to solve. So one approach to tackle this integration problem is to use integration products that are mostly based on configuration and not code. So these are like, so we have created EAIs, ESBs, and special DSLs to handle these specialized integration products. So, but there's a specific problem. These approaches are not that agile. So they basically disrupt the edit, build, run, and test cycle that developers follow. And this is not a experience that developers like that much, because they like to be in control, to do anything that they like, to dig into specific scenarios and so on. So the other end of the solution is using a general purpose programming language, like, for example, Java, C#, JavaScript, and so on. So these languages do provide the agility, but the developers have more things to implement. They have to solve the problems that you get with integration. So that means you have to write your code to implement this logic, or you can also use other complicated frameworks like Spring and Node and so on that you have bolt into your existing programming language. So all in all, this approach is agile, but it is not integration simple. So this is a problem. Integration simple means you have to write all this code and so on. You have these concepts out of the box as main concepts in your environment. So you don't have both at once. So if you use this tool or the other tool, the two approaches, they fall into different categories. And this difference, we call it the integration gap. So we have seen how this integration gap comes. So what can we do about it? So our solution for this is Ballerina. Basically, Ballerina is a compiled type-aware, network-aware concurrent programming language, and this is used to basically make sure the integration gap is solved in a developer-friendly manner. So we will see what are the features that we have implemented and the design philosophies and the approaches we have followed in order to do this. So let's start with a simple hello world program first of all. As a customary thing you would do with a new programming language. So this is it. So the Ballerina syntax is very familiar if you have used programming languages like Java, C++, JavaScript, and so on. So it's not a very high learning curve you have to go through to know to go through the language. So here you can see we have packages, the IO package we are using here. We have imported that and basically done a print line to do hello world. And so then afterwards we'll do another version of the hello world. This where the main integration related features come in. So we'll do a hello world in as a service. So you can see here that the caller will do a get to a service, which will return hello world as a response. So let's see how Ballerina does this. So this is the code to do that. You can see here in Ballerina we have service as a first-class citizen. So that means there's a language level concept called a service. So here we basically just declare an HTTP type service called hello, and we just say bind it to this port to a specific endpoint. So we have used an anonymous endpoint here. And after that, we have another service level concept called a resource. We just give a name here. And then comes another inbuilt feature we have called endpoints. So the endpoint is a caller, and the caller can be used to send a response back. So likewise, so what we simply do is we create a response like this, set the payload, and tell the system to respond back to the client. So in that way, there are a lot of features in the language that makes the integration concept easy to grasp and easy to work with. So, and we'll get into this more, some details later on. So basically, this is how we would do a simple hello world. And let's get into the concept of connectors in the language. So connectors again are a main concept that's there in the language itself. So I'll show you a simple scenario where we use a Twitter connector to do a tweet outside from a program. And so this is a sequence diagram for that. So basically the caller do a post to the client program, and using a Twitter connector, we do a tweet, get the response from the from Twitter, and send it back to the client. So let's see how the code looks like for that. So this is basically it. And again, the same concepts are there. Starting with the endpoint, it's of type Twitter, and we basically fill in the properties like the client ID secret, the access tokens, and so on. So we get those using the configuration API, because those are secrets you don't want to hard code in the program. And then the service. So the service, you can configure the service properties using annotations. And then, so it's a matter of then using the endpoint that you declared earlier. So something you would see is, so TW is endpoint here. There's an arrow and tweet. So arrow notation basically means it's an action that we do on the endpoint. So we make the specific distinction between function calls and actions in the language. So it gives the idea that we are actually doing a network call through a connector, not a simple normal function call. So so it's more clear when you look at the code and want to like see what you're actually doing here. So you can see here, we just call the action in the Twitter endpoint, we get the payload, and we respond it back to the client. So this is basically the same pattern we use with other type of endpoints as well. For example, even if you are using a database connector, so those also we have modeled as specific endpoint types. And let's look at some special support we have in the language for Docker and Kubernetes. So being a cloud native programming language, having this support is critical. So what we have done is we have gone a step extra by having like language level awareness for container systems and orchestration systems, where it's very easy to deploy to a Docker and a Kubernetes environment. So so what you do is when you are writing code and doing the deployments, you don't especially do any extra steps to deploy into these environments, but what you would do is while in the same code, you basically annotate your specific constructs like endpoints and services, saying, okay, I want to deploy this into a Kubernetes environment, and that's it. So inside the code itself, you have stated your interest, and after that, when you are building your Ballerina program, it will automatically build the Docker images and the Kubernetes artifacts for you. So then there's no additional program logic you have to write in your applications. Those are intact, but it's just a matter of adding some additional annotations to be compatible with this target environment. So you can see here in the endpoint, the listening endpoint, you just have to annotate it with the Kubernetes service annotation, saying the service type and output we have used here, and the name. And also in your service, you annotate that with the Kubernetes deployment annotation, which says what's the image you have to use, the name, and so on. And also extra configurations, for example, your secret information like the passwords, access tokens, and so on, you put in a TOML file. You can include those as well with this config map annotation. So likewise, you can see how it's very convenient using this mechanism. At the end, you do a build, and straight away you can deploy this into to Docker or to Kubernetes. And we'll look at some other features we have for service, the communication resiliency. So I'm taking one of those examples using circuit breaker. So we have more features like timeouts, load balancing, and so on also, but I'll be looking at circuit breaker specifically here. So we have a small demo scenario here where a client will be calling a service, here the hello service, and we do a outward call to another API. So here we call Simpson Courts. It's a web service that's hosted in the internet, and the problem with that service is it may work at times and it may fail at times. So there can be timeout issues, outages from the server, and so on. So to handle this, so we are using this circuit breaker pattern. The idea is when you do request to a target endpoint, if it fails at some point and it fails for some time, there's no point in hitting that same service from our client continuously, because being failed for several times, there's a high chance it will keep on failing for a longer time. So then it makes sense for us to handle the failure for some time and to retry later without adding more load to the target service and delaying our logic as well. This is that scenario. So when we are calling Simpson Courts, so if there's an outage here, what we do is our circuit basically trips, and the circuit basically goes to an open state. Then we don't go to the external endpoint, rather we stay at our service itself and do some logic there. And after a while, we can retry the service later. So you can see this is how we do it. We have a extra configuration to the endpoint where we put some circuit breaker specific properties, giving how much time to use for the reset, what's marked as an error in the request responses, the specific status codes, and so on. So then when we are doing a call, you can see here the endpoint called Homer. We do a get to that. The response can either be the successful response or it can be an error. So error means most probably the circuit is open. We can do some other actions to handle that. So this again shows how the resiliency features of Ballerina works. So they are built into the endpoint services that we offer, making it easy to program with without using any external libraries and so on. And another main concept of Ballerina language is sequence diagrammatic. So that means, so I have shown you few sequence diagrams earlier to show some scenarios. So because that's the natural way of showing a flow of what's happening when multiple systems are in use. So what we have done is, why not put that to the language as a backing concept as well. So that's where we have all services, endpoints, and so on designed to support this concept. So basically, from the service, the caller, all our code and the constructs are compatible with the sequence diagram model. And what we can do is, even in our tooling, if you go to the Ballerina Composer, all the code we write, it will automatically give you a a sequence diagram view of the code. So concepts like endpoints, workers which are like parallel executions in the programming language, those are very naturally visualized as a sequence diagram there. So we have this support in the Ballerina Compose and also in our VS Code plugin. So it's a very easy and natural way to visualize what you have done, the high level design and the flow of your program. So let's go into the observability aspects of the language. Observability is critical when we have a complex system, because having a target system being observed is very important in a way that you can monitor and see the state of the internals and how it's working throughout. Rather than waiting for an incident or issue to happen, we can predict and take measures beforehand. So because of that, having the observability features in your applications and the runtime is very important. So what we have done is in the language and the runtime itself, we have baked in some observability features to help with this. So we have distributed tracing, metrics for aggregatable information, and of course logging facilities as well. So let's go into some details on this. So the tracing features, we do distributed tracing using the open tracing standard. So that means any open tracing provider can be possibly supported with Ballerina. So we have currently implementations for Jaeger and Zipkin. So it's a matter of implementing that compatibility layer, and all the features that comes with distributed tracing will work from there on. So this is an important feature as well, where in Ballerina, when we have lots of microservices, complicated distributed environment, it's critical to be able to trace a specific flow and so on, to be able to debug and see what's happening throughout. So these can be done with the features that we support with Ballerina. And then the metrics and visualization. So for the aggregatable stats we have, for example, the number of service calls that are going in, the errors we get, the latency numbers, and so on. So all of these are also pumped into Prometheus by default. So we have direct support and integration Prometheus, and also we have some dashboards created for Grafana as well. So this is the out of the box supported the combination for metrics and visualization. And then we come to log processing, which is an important part of our ecosystem. So anything, so specific events, standalone events in the system, we log to files and other centralized systems. So for this, we support systems like Humio, Elasticsearch, Kibana, Logstash, and so on. So Humio specifically have some special features that improve the log processing features of the system, and have some value-added features that we can use. So on that, I guess PJ is the expert in this area. Let me hand over the presentation to PJ, and he can continue from there. Audio, PJ.
All right, can everybody see my screen? Yes, it looks like everybody can. Okay, so make sure that I'm able to advance. All right, so I'm PJ, and as Njana mentioned, I am the developer advocate at Humio. So for my part, I'll be giving you a quick overview of Humio, and then we'll talk a little bit more about how to integrate it with Ballerina and some of the good parts there. So traditionally, when people use things like Splunk or Elastic, they're looking to meet their logging needs, their observability needs, especially with the advent of DevOps and things like that. Um, but when you're looking at things like Splunk and Elastic and homemade solutions, they come with a whole host of problems, expensive licensing, difficulty scaling, delays in getting the data, especially with those homegrown inventions that people put together. So the idea behind Humio is with simple pricing, real-time live data that is searchable and shareable, we kind of look to conquer those common problems that we've seen in all the other logging solutions. And similar to what Anjana was saying with Ballerina, the whole point was to kind of solve a problem that we were seeing ourselves. So each of these other options like Splunk and Elastic and logging as a service and homemade things, they all have so many like major shortcomings that Humio was lucky enough to be able to build and kind of avoid or fix the things that were going on. We focused on flexibility because it's the key to meeting the needs in the modern world of application development. In the simplest sense, Humio takes raw data and uses machine level resources to process that into valuable, actionable information. If you see in this diagram here, you have very basic information that's being processed. In this middle section, the in-memory state machine, that could be your local cloud, your private cloud, a public cloud, an on-premise server setup that you have, but somewhere where Humio is running and selecting all that. And it's creating information that people can actually take action on in real time, meaning that they don't have to wait for the data and then eventually make decisions. We've actually had folks that deploy their application, do a few things on it, and watch the Humio logs come in to make live code changes in their staging environment, which is exactly our whole goal. So deploying Humio is actually incredibly easy. It can be done on-prem, like I said, on humio.com. We'll host it for you. You can do it in your own cloud infrastructure, on public cloud infrastructure. We are big container users, so we make it as easy as possible to take advantage of tools like Docker and Kubernetes. Just like Ballerina, we're built for the applications of today's infrastructure. We're not thinking about, what do we have to do if someone has, an ancient 386 that's running IIS. We're focused on the way things are moving forward, not the way things used to be. Integration and data ingestion is also something we take very seriously. So we continue to build the number of options that we can give for integrating and using Humio for your logs. Here we have just a few. So a lot of folks are already using kind of the Elk Stack, the Elastic Logstash Kibana solution. We can easily convert that and start taking it in. We have plenty of languages. We can do it directly through GitHub. So there's a lot of options here. So we make a few assumptions here when we talk about integrating Ballerina and Humio. And the first is that, you have an application and Ballerina is configured the way that Anjana just kind of explained it. And that makes integrating into Humio pretty simple. There's various techniques for setting your data to Humio, like we just talked. And in this example, we're just kind of use the platform integration method using the Ballerina application that Anjana mentioned. And deploying it with Kubernetes as an example. So we're already using Kubernetes. We already have that understanding. So we'll start with Helm, the Kubernetes package manager. That's really easy to install, and you can find that. Our next goal is once we have Helm installed, we're going to create within our project a file named humio-agent.yaml. And we have all the directions for this in our documentation, so feel free to check that out. Once we've done that, we'll replace the host section of that file with the host name of our Humio installation. So if you're hosting it at Humio, it's maybe cloud.humio.com with some specifics, or if you need your own servers or your own setup. Then we'll take the ingest token that we have on our Humio account, assuming you've set that up. We'll take that from the repository and enter it into the ingest token section of the YAML file. Then all we need to do is run a simple Helm command to get the logs running. And you see it right there. It's just Helm install stable fluent bit with the information that we've provided, so it's going in the right place. And that's really all there is to it. So you have your Ballerina app set up. You're able to ingest your logs in Humio, and in absolutely no time, you start to see what's going on. Just 5, 6 simple steps, and you're ready to roll. And we actually have a blog post with more in-depth directions and links to see that, and I'm sure we'll link it at the end of the webinar. Again, just like with Ballerina, if you get in any trouble, we have docs, we have support. Feel free to jump into our Slack, hit us up on Twitter, whatever it takes. We want to make sure that you're getting the log interaction that you need. There's people always standing by. So between Humio and Ballerina, you can create the connections necessary to bring together all the pieces of a modern microservice architecture. And with the focus on the information you need and the application performance you want, Ballerina and Humio team up to provide the full package. That said, as Jana mentioned, there's going to be many pieces that are part of your ecosystem, from cloud runtimes, configuration systems, messaging, protocol, service meshes, databases, observability. These are all key components to making sure your application runs well and runs all the time. And Ballerina and Humio try to work together to kind of bridge making these parts flow together seamlessly. Additionally, if you want to learn more or get involved with Ballerina, you can take a look at these links here. It is an open source project, so Jana, I'm pretty sure people can jump in and help out if they want to fork and pull and do all the good things involved in open source. Is that correct?
Yes. We are a fully open source project. Anyone can get involved with the discussions and also help in issue reporting, documentation, anything. So all the discussions are open and public. So we welcome any participation from anyone.
Awesome, and it's cool that you build a community around these open source projects, and it's wonderful that Ballerina has reached out and we have the opportunity to kind of bridge the gap between a great open source project and a wonderful observability tool in Humio. So hopefully everybody got a bit of information out of that, and I think that's all we have. And Jana, correct me if I'm wrong. Is that us for now?
Yes, that's it. I hope everyone enjoyed the session.